Today we continue study circles, problems about circles. Okay, first of all, this is a geometry. You probably have to wait for a long time in the school to study geometry. So this subject might be a bit difficult to understand because you have never seriously learned geometry. If you have any questions, please stop me and I can ask me. Okay. Okay, so first of all, let's recall the basic formulas for the circles. If we have a circle, right? You have a circle. You already did the homework, right? You have a radius. I is the radius. The circumference is going to be 2 pi r. Okay, and the area is going to be pi r squared. You have to know these two formulas. Okay, and in the future, if someone asks you what is a pi, pi is actually the area of the unit circle, or half of the circumference of the unit circle. So pi is going to be the area of the unit circle. When I say unit circle, means the radius equal to 1. Okay, so radius equal to 1. Okay, or it can have to say half of the circumference of a unit circle. Okay, yeah, unit circle could be we just say because in unit circle it's part, it can be in different position, location. Okay, so that's it. Then there's the other versions of formula. For example, if I want to use a diameter to describe the formulas, how can I do, right? Use a diameter. Diameter d is going to be half of the radius, right? So I can replace r by d, okay, with d, okay? So how can I do that? You see, c equals 2 pi r, right? 2 pi r is pi times 2r. So here just pi times d. So diameter times pi gives you the circumference. And how about the area? Area is a bit complicated. So I is going to be half of a d and the square. So you can take a 2 square out. That'd be a quarter of a pi d square. Okay, so there's another two versions of a formula. Now, both C and D depends on the diameter, right? Both C and both area and the circumference depend on the diameter, but then they also depends on each other. Okay, so A depends on C, C depends on A, right? A depends on C, and C depends on A. Okay, good. So can we find a relationship between those two? No problem. Now sometimes you're given the circumference, you have to find the area, not the radius, not the diameter. You're not given this. So from the first formula, I know D is going to be C over pi, right? That the diameter depends on the circumference. Then A is going to be quarter of pi. What is D? D is C over pi and the square, right? So now you simplify it. C squared pi squared. So you have a pi on the top, pi squared at the bottom, cancel 1 pi. Okay? Cancel 1 pi. And so then you finally will get C squared over 4 pi. Okay? So that's also the, how shows how does the area depend on the circumference. Now we can also find the formula, express C in terms of it, because in the future, sometimes you're given one formula, but you have to rewrite the formula, get another formula. if you're given the area instead of the circumference, you have to find the circumference. So we still use this common formula. Okay, then let's see. So D is going to be, yeah, I think we just solved this from here. So C square equals 4 pi times A, right? Right, that's another formula. Then the C square, C is going to be square root of 4 pi A. Very simple, that's just simple. And then sometimes you can get integer, sometimes you will not. But at least you can take square 4 out. It's 2 square pi A. Okay. Anyway, so the circumference and the area, they have this relationship. Okay. Now, usually, okay. Yeah. So if we have a circle, okay. So for the circle, C squared minus 4 pi A is always equal to 0. Okay. But if an arbitrary closed curve, no, that's just the more advanced mathematics. Okay. So the circumference of C and area is A. Do we have this equality? No. Okay. So area of the circle, if the C is the same C, the area has the largest possible, circle has the largest possible area. So usually you always have this inequality, okay? Okay, that's a very advanced topic. I'm not going to go through that. Okay, now let's do some exercise. We find all the relationships, okay, among those quantities, circumference, diameter, and the area, okay? So here's a question. If the circumference of a circle is 8 centimeters, okay, what is area? Okay, so if you already know the relationship between the circumference of the area, and then you're okay, you know, circumference C squared equals 4 pi A, right? So now from here, you can get A. A is going to be C squared, right? It's going to be 8 squared over 4 pi. Then you simplify it, okay? A squared is 64 and divided by 4 pi, and that's 16 over pi. So don't estimate pi is a number, and that's perfect, looks fine, okay? And then if the numerator and denominator have a common fact, you can cancel it, okay? So when this is algebra, if we have A and B and C, and then this A can be canceled out. That's the only way you can cancel some factors. If a numerator and both denominator both have the same factor, okay? Yeah. Now, if A plus B over A C, you cannot cancel A. Okay, it's not going to be B over C. They're totally different. Okay, you cannot just because A is A plus B, not A times B. Our next question is if the area of a circle is 8 pi square centimeters, what is the circumference? Now you can use above formula to solve it. Okay, it's up to you. Okay, if you know C squared equals 4 pi A, then this is a very simple formula, right? And use this formula will be much quicker, right? You don't need to go through the radius. Okay. So you are given the area is 8 pi, then you get 32 pi squared. Okay, so now both sides it's a square. You have to solve this quadratic equations, right? C is going to square through 2 pi squared. So let's try to figure it out. it's going to be 32. 32 is a 16 times 2. So actually it's 4 squared times 2. And here's a pi squared. So whenever there's a square that you can get rid of, right? It's going to be square 4 square. And right? Let's try. I'm not going to skip that step. 4 square, square root 2, square pi square. So square 4 square is 4, square root 2 is still there, and square pi square is pi. Okay. And don't forget put the unit. Okay. Don't forget put the unit. So that is going to be 4 square root 2 times pi. You have to express in a simple form, not like a square root of 32. But so yeah, we have to deal with the equation. So let's talk about equations. Right? How to solve this equation x squared equals a, right? Here we assume a is positive, okay? So in general, the solution, if there's no restriction on x, you have two solutions. The reason is the first solution will be the positive. We denote the solution by square a, but square a could be integer, okay? If a is special, if a is a perfect square, then square a is going to be integer, okay? But there's another solution, it'll be negative square, don't forget, okay? If there's no restriction on the sign of the x, right? So there will be two solutions. The reason is plus or minus square a square is going to be square a square, which is a. Okay, so that's that's why you should have two solutions. Now, when a is a perfect square, then x is going to be is an integer. Okay, and for square root, we do have some formulas. Square a times b is going to square a square b. That's what we always use that, right? And square a over b is going to be square a square b, right? And the square root of p square, it's a perfect square, equal to p, right? And the square root square a square, it's going to be a. So those are the here a, b, p, they're all positive numbers, okay? So those are the p positive. P is not positive. Be careful. It's not going to be p. Right? That's not false. So p is positive. Okay. Right. So p is positive. If p is not positive, so what happens? Square root of a -2 square, right? Is not going to be equal to -2. Right? You know that, right? So this is actually is going to be square root of 2 square, which should be equal to, not a -2. Right. So after we understand those the stuff, then we can solve the following problem. We're going to compare both, right? The circle, okay? Here's a circle. If a circumference of the circle is equal to the perimeter of the square, what's the ratio of the area? Okay. So these two have the same, yeah, they have the same perimeter. Of course, the circle, they have the same perimeter. The perimeter of the circle is called circumference, has a different name. Then we just assume that they have the same perimeter. Okay. What is the ratio of the area? Okay. So I write circle on the left. That means a circle over the area of the square. So we want to compare those two, which will have, they both have the same circumference. Okay. So I think that area of the circle should be larger than the area because with the same perimeter. I already told you that. So with an arbitrary region, circumference A, c square is going to be greater than or equal to 4 pi. Okay, is greater than or equal to 4 pi A. Okay, so the area has the largest possible. The circle has the largest possible area among all the closed curves. Okay, so that means the area of the square should be smaller than the area of the circle for the same if they have the same perimeter. So we should know that first. Okay. So the area of a square is smaller than the area of a circle if they have the same perimeter. Okay, we can see that. And how do you compare them? Okay, so take a look at the circle, right? So it's circumference, and this is also the parameter is also denoted c, the same c. So I'm going to find the area. Area is a c squared over 4 pi, right? But how about this one? Area is going to be, this is a circle, this is a square. The area is going to be, the edge length is going to be c over 4. So c over 4, right, and then square. So that's the c squared over 4 square. Okay? Then you can see they have the same parameter here, right? So the ratio is going to be c squared over 4 pi and c squared over 4 squared. So after you simplify it, circumference cancelled out, and then 4 cancelled out, just 4 over pi, which is greater than 1 because the area of the circle should be larger than the area squared. Now, if you don't use above formula to derive, you have to go through the you have to go through the radius, and that's okay. Let's redo the problem. Okay, step by step. Forget we only know the basic 2 formulas. Okay, so let's see. So I calculate the area. The area is going to be pi square. I calculate the area. This is a circle. This is a square. So a square, right? We want to find the ratio. So what we are given is they have the same parameter. The left-hand side of the parameter is 2 pi r. This is a 4a, right? 4a is the parameter of the square. So that's the relationship between them. Okay. Then r over a is going to be 4 over 2 pi, which is going to be 2 over pi. Okay. So that's the ratio of the radius to the edge length. So now we are going to find this ratio. So it's pi r square a square. Okay. So pi is pi, r square over a square is r over a square. But we already know r over a square. So it's going to be pi 2 over pi square. Okay. Then you simplify this. Okay. You should be able to get the same answers. So you get pi 4 over pi square, and then pi square cancel 1 pi, you get pi over 4. So same result. But you should at least have to memorize those 2 basic formulas about area in terms of radius, in terms of edge length. Okay. Okay. All right. I wanted to find out solve the following problem. So I have this pizza, right? It's a circular pizza. Then I have another pizza, square pizza. Okay, I know they have the same area. If they have the same area, okay. So what is the ratio of the pyramid? Okay. So now we assume they have the same area. If they have the same area, I believe that the circle has a smaller pyramid than the square. So Mongolian people is very smart. When they build a house, they also build a circular house because they have a limited material. Okay, if you make a square house and then you take, for the same area, it takes more material. Okay, it's because the pyramid is longer. So suppose you go to store, you want to be, maybe your parents have a vegetable garden, right? And they have a fence. They want to put a fence there to prevent the rabbits coming to eat the vegetable. So actually, if they have a fixed budget to say, I'm going to have a 50 feet long fence, right? You bought it from a store. So what kind of shape should include? Most of people, of course, choose a square, choose a rectangle. It looks maybe good, I don't know. But you do the calculation, which one gives you a large area, right? For the fixed pyramid. And you see that the square as a circle has a larger area. So I don't think it's a bad idea to make a circular vegetable garden instead of square. Okay, so think about this options in the future. And our above example shows you that the circle as a, the circle has a larger area than as all the squares rectangles. Okay, so now we assume they have the same area. Then which one use more material, right, on the boundary? So we have to do the calculation. This is application of mathematics. All right, they have the same area. Okay, so let's see. I'm going to. I can use a formula for the circumference for the pyramid, right? In terms of area, right? So we have square pi over 2, someone? Got it? Nina got it? Okay. There are two ways to do. One is we express the pyramid in terms of the area. If we can do that, then you can just compare it directly. If you only memorize two basic formula, that's okay. So the area is going to be pi r squared, and this one's area is going to be a squared, right? So they have the same area. So that means this is a given, that equal, right? So what do we have to find out? Find out the ratio of the pyramid is 2 pi r, and this is 4a. So we have to find out, after we simplify, it's pi 2 and r over a. So if we find the ratio r over a, I can solve the problem. So we are given the information, given this information. So therefore, r squared over a squared equals 1 over pi, right? Right? So then you plug into here, and you cannot plug in directly. You have to find it r over a. So r over a is going to be square root 1 over pi. So we put it there. So the ratio is going to be pi over 2 square 1 over pi. Now the question is how to simplify, right? Casey got square root pi over 2. That's correct. So you have pi, you have a 2 square pi, right? But square pi and pi, if we simplify, that is going to be square pi over 2. Okay. The reason is pi can be written as square of pi times square of pi. So you have 2 square pi there. Good. All right, another question is, suppose you always make a large cake. Yeah, this is a large cake with a radius r. Now you decide to make 4 smaller cake, but you want to make sure the 4 smaller cake have the same area as the larger one. Okay, so then you want to see how small the radius of the radius of the small circle. So if the area of the larger circle is equal to the total area of 4 identical small circle. Okay, find the ratio of the smaller the radius of the small circle to the radius of the larger circle. So if you already know the largest circle, it's the radius is 6 inches, right? It's a larger pizza, 6 inches. You want to, or cake. You want to for a smaller one, but you want to make sure because you already have the same the same amount of material, right? And the thickness is supposed the same. So you don't want to waste the material, right? So you want to get exactly 4 smaller circular cake. Then you have to do the calculation. How big of the circular cake, okay, you can make, right? So let's do this. Okay, this is it's a good problem, right? So what's the answer? Anyone have answers? Okay, you what you do is you write down the area for the larger circle, write down the area of the 4 smaller circles. Then you set them equal, right? Then you find the ratio. Okay, so what you do is that the area of the larger circle is pi capital R square. Now the area of smaller circle is pi little r square, but you have 4 of them, right? So multiply 4. Yeah, Michael, you did a good job. Thank you. So they're the same. So now you simplify it, right? Both sides you have a pi, so pi is gone, right? So you get 4r squared. Now you want to find r squared, r over little over capital R. So r squared, equals 4r squared. So you add them together. No, do the ratio, right? So little r squared over capital R squared is going to be 1 over 4, right? Right, you divide both sides by 4, divide by both sides by r capital R squared. So that's what you get, right? First of all, if you want to step by step, it's fine. It's 1 equals 4 over r squared. Then you divide by 4, then you get that, okay? Then this little r capital, that square equals a quarter, right? So then you solve the r over cap, and that is going to be square root of 1 over square root 4, right? And that is 1/2. Good job. Okay, now let's think about this. So that means the smaller circle has half of the radius, the larger circle. So let's go back to here. It's a larger circle. This is a capital R, right? Little is half. So those smaller circle, let's put it back, okay? Smaller circle. Okay, this smaller circle is going to be half of R, right? So actually, let's imagine. So you get this, right? So you fill that part. Then you also fill this part. Okay. Now, what is left? You have this part, right? Right? You have another part. So my question is, what is the area of the yellow part? Well, you already delete 2 circles here. So you already use the 2 circles. So the remaining area, I think the yellow one should be equal to yeah. So you get this, all right? Right, so because we know the total area is going to be the area of the larger circle. So now you already draw 2 small circles inside larger circle. You already use 2 circles, right? So the remaining part, okay, the remaining part divided by 2 should be the area of the 1 smaller circle, right? Right, use a subtraction. Yeah, use subtraction. So this, otherwise it's hard to see, why the circle in the yellow color will be the area of the area of the smaller circle. Now it's clear, right? Yeah, it's interesting. Okay. Yeah. So all you have to do is just the name variable, right? The radius for the larger circle, radius for the small circle. And you write down the total area for the small circles and the area for the larger, and you set them to equal. If you set them to equal, then you just solve this, modify this equation, and you can get an answer. Okay. Okay, so let's take a look at the next problem. If the ratio of the circumference is of 2 circles is 1:4. Okay. What is the ratio of the areas? I can change it 1 to 4, 1 to, I can change it 1 to 9, 1 to 4. Okay, what is the ratio there? Don't be confused about this, okay? It doesn't matter. The number. So 1 to 4. So I have a smaller circle and I have a larger circle. Okay. And I know that ratio. I just want to know the ratio of the area. The ratio of the circumference. All right. So now if you use a formula, this formula c squared equals 4 pi a, it'll be much easier. Okay. The reason is because you already know the relationship of the area and the circumference directly, right? So if you use that, it will be much quick. For the smaller circle, right, area is going to be 4 pi. Smaller area of small circle is going to be the area, the square of the circumference of the small, right? Then 4 pi a larger one is going to be c large square, right? So you are given the ratio of their circumference, right? So then you take the ratio 4 pi as, 4 pi a large, right? That would be much quick to do. Okay, so this cancels out. That gives you a ratio of their areas. But left hand side, the right hand side is the square, so it's going to be CS CL square, and which is going to be 1 over 4 square, which is 1 over 16. Okay. Now you can also use the radius if you don't want to use the formula between area and the circumference directly. And how do you do that? This is little r, this is capital R, right? So you are given r over capital R is going to be 1 over 4. Okay, that's a given. Okay, you want to find out the ratio of the area. Area is going to be pi r squared over pi capital R squared. So that's also much easier. It's pretty easy to do, right? So that's the ratio of the areas. So that's going to be just r squared over r squared. So that's little r over capital R squared. Then that is 1 over 4 squared, which is 1 over 16. Okay, Zach, it's 1 over 16 because 4 squared is 16. Okay. Yeah, be careful about this script. So for practice, I want you to do the following. If the opposite way, if the ratio of the areas is 1 to 9, right? What is the ratio of the circumference? Okay, you have two circles. Okay, right? You have two circles. I know the ratio of the areas. I want to know the ratio of their circumference. Okay, this is the area is a large, small, right? All right, so let's use radius instead of other formulas, right? Use radius. You have to write down what you are given. You are given the area, so the ratio of the areas is going to be 1 over 9. Just write down that. what do you have to find out? You have to find out the ratio of the circumference. It's 2 pi r, 2 pi capital R. Okay, so that's it. You use the information on the left to find the information on the right. Okay, so you get little r of a capital R. Okay, and that is square is going to be 1/9. So that implies is a square 1/9. And square 1/9 is a 1/3, right? Because the square of 9 is 3. But on the other side, this implies 2 pi r over 2 pi capital R is going to be just little r, just the ratio of the radius. So that's why it's 1/3. Okay. All right, so we have a circle with a radius, and radius equal to equal to 4. Okay. Then I know the air. Then I have many smaller circles, which I have 64 identical circles. Okay, smaller circles. So if the area of the largest circle is equal to the total area of all those small circles, so what is the radius of smaller circles? Okay. What is the radius of a smaller circle? Okay. Any idea? Well, just kick it, right? So area of the largest circle is pi for square, and the area of smaller circle, right? You want to find the radius, so it's going to be pi little r square, but you have 64 of them, right? That's it. Then pi canceled out, right? So little r square equals 4 square over 64, right? 4 square over 64 is simplified, okay? So it's going to be, right? It's going to be, you can do the following, you can 4 square, 8 square. So it's going to be 4 over 8 square, right? So it's going to be 1/2 square. That's going to be 1/4. Yeah, I don't need to calculate that part. So I just find the radius, right? It's then equal to 1/2. Right, our next problem is I have a square. This is a square. Inside square, I have 4 congruent circles in square. Okay, 4 identical circles are inscribed in a square. In square means they touch all the sides. Can leave no, yeah. So my question is, what is the total area of the circles to the area of the unit square? Yeah, find the area of 4 circles and the area of the square. It's not necessarily unit square, but the ratio will be the same. Now, clearly the ratio will be smaller than 1. Why? Because the 4 circles do not occupy the whole square, so they have less area. Okay? Less area. Now, question, how do you solve it? All right, so let's do this problem. First of all, we have to find the relationship between the radius and the edge length. Okay, so from the picture you can see that A is going to be double the diameter. It's going to be 4r, right? Clear, right? You know, so radius, 4 radius gives the edge length of the square. Okay, then the ratio is going to be 4 times area of the circle, pi r pi square, right? This is just a square. But r square, you know, a square is going to be 4r, right? So you can compute this. Then you simplify, it's going to be 4 pi r square and 4 square r square. So r square is gone. So what is left is just pi over 4. Okay, what is left is just pi over 4. Okay. Remember, for the square we studied before, right? The diameter is d, here's a, right? We record this, right? We use the Pythagorean theory, d square equals a square plus a square, which is 2a square. So the relation for d is the square root 2a square, which is square root 2 times a. So that's a relationship. Okay. Now, once you know this relationship, then we probably can do the following problem. I have a circle. I have inside the circle, I have a square. Okay. A square is inscribed in a circle. Okay. Find the ratio of the area. Okay. So the ratio of the area of the square to the area of the circle. All right. So the key point is, my hint is, draw the diameter of the circle, which is also the diagonal of the square. Okay, that's the key point. Okay, you draw those, then the remaining part is easy. Okay, So this is a D, right? That's A, right? So the relationship between D and A is this, right? But D is also the diagonal of a square, is also the diameter of the circle. That's my hint. Can you do this problem right now? Okay, so your answer is 9 minutes left. Oh my God. All right, so this is a problem. I didn't get answers from you guys. Okay. So the ratio of the area, right? The ratio of the area of the square is going to be a square. The area of the circle will be pi d square, right? You know, express in terms of the diameter, right? D square over 4. Do you remember that, right? The radius, right? D square over 4. Because pi r square, right? R is half of that. You can use this. Okay. Then that's a square. Here's a pi. D square is, is 2 times a square, right? D square is 2 times a square, so that's square. Then you simplify it, and that's going to be 2 over a square over 4, right? Okay. So a square is gone, and you get pi over 2 in the denominator, that's going to be 2 over pi. If you want to use D, maybe a little bit complicated, yeah. So anyways, you get the number should be smaller than 1. Right, should be smaller than 1. If you don't use a diameter, probably a little bit easier. Use a radius, yeah. Okay, so let's use a radius. If we use a radius, the formula may be a little bit simpler, okay? So here, if we use a radius, R and R, right? Here's A. So let's find the relation by R and R, right? 2R squared is going to be, that's the diagonal, right? It's going to be A squared plus A squared. So 4R squared equals 2A squared. So R squared equals half of A squared. That's fine, right? Or A squared equals 2R squared. Okay. Then you find the ratio of the area. Area is square and the pi r square. So all I have to do is replace a square by 2r square. Then r square cancels out. You get 2 over pi. So there are many ways to solve the problem. Okay, that's probably more natural way to do. All right, so next problem is I have a circle. Right? This is a diameter. So what I'm going to do is I'm going to evenly put the 4 congruent circles. I cut. Okay, cut it in the hole. Okay, identical, right? So the remaining part is this. So my question is, yeah, what is the what portion of the circle, larger circle, is a shared region? Is a shaded region? Okay. So you have to use actually you find the ratio of the area of shaded region to the area of circle. Okay. To do that, just name the variable, the area of the little circle, the radius of the little circle VR. Okay, then you have the radius of the larger circle, right? So large a radius, this is a capital R, that's little r. So what's the relationship with capital R, little r? Right, so let's find the relationship between capital and the little r. I think clearly capital R is going to be 4 little r, right? From the picture, you can see that, right? Okay, that's the relationship. Then the shaded region is going to be on the top, right? So you have to use a difference. Otherwise, how to calculate the area? The area of a largest circle minus area of a 4 smaller circle, right? 4 times pi r squared. And this should be over capital R squared, right? So that's whatever this is the ratio. The ratio of the area of the shaded region over the area of the larger circle. And the area of the shaded region, you cannot compute directly. You have to take the difference, right? You have to take the difference. So now you have this. You have a capital R, you have a little r. You have to replace capital R by little r in order to solve the problem, okay? So it will be 4r squared, 4 pi r squared, 4r squared, and the pi, right? And now you will see the numerator will be 16r squared, pi, and here's 4 pi r squared. Then you have a 16 pi r squared, right? So 16 is going to be that's 12, right? And here's 16, okay? So it's a 3 over 4. Clear? Yeah, 3 over 4. Okay, so let's stop here.